Ever noticed how gases seem to react like they're following a perfect recipe? Just like measured cups of ingredients, gases combine in simple, predictable volume ratios but only when measured under the same conditions of temperature and pressure. This fascinating observation became known as Gay-Lussac's law of gaseous volumes. And it forever changed how we understand chemical reactions involving gases. This law was introduced in 1808 by Joseph Louis Gay-Lussac, a brilliant French chemist and physicist. He carried out experiments by reacting gases like hydrogen, oxygen, and nitrogen, all under carefully controlled conditions of temperature and pressure. What he found was remarkable. The volumes of these gases always reacted in simple, whole number ratios. It wasn't just coincidence, it was a pattern. And it became one of the most elegant laws in chemistry. The law says, when gases react, they do so in simple, whole number ratios by volume, and this also applies to the volume of the products formed. The only condition? All volumes must be measured at the same temperature and pressure. So, just like we use moles to balance equations by mass, we can now use lighters to balance reactions by volume. It's chemistry you can measure with a gas jar, not just a scale. Let's take a classic example straight from your textbook. Hydrogen reacts with oxygen to form water vapor. And here's how the volumes behave. 2 volumes of hydrogen react with 1 volume of oxygen to produce 2 volumes of water vapor. That gives us a simple ratio, 2:1:2. Exactly the kind of whole number relationship Gay-Lussac observed. No decimals. No guesswork. Just clean, measurable chemistry in volumes. Here's another classic example of Gay-Lussac's law in action. 1 volume of nitrogen gas combines with 3 volumes of hydrogen gas to form 2 volumes of ammonia NH3. That gives us a clean volume ratio, 1:3:2, and as long as temperature and pressure remain constant, these ratios are always simple, whole numbers. It's like nature is measuring with perfect cups of gas. Gay-Lussac's law hinted at something much bigger, that equal volumes of gases under the same temperature and pressure contain equal numbers of molecules. He didn't know it yet, but this idea would soon be confirmed by Avogadro's law. So, when gases react in simple volume ratios, they're also reacting in simple molecular ratios. 2 liters of hydrogen plus 1 liter of oxygen equals to 2 liters of water vapor, means 2 molecules plus 1 molecule equals to 2 molecules at the molecular level. It's not just about volume, it's about how molecules behave predictably in gas form. Here's a very important point. Gay-Lussac's law only applies when gases are measured at the same temperature and pressure. Why? Because changing temperature or pressure changes the volume of a gas, and that would break the simple ratios we observe. That's why chemists often use STP conditions, that standard temperature and pressure, to keep gas volume calculations accurate and consistent. It's important to remember, Gay-Lussac's law applies only to gases. Why not solids or liquids? Because gases can expand and compress significantly, while solids and liquids cannot. Their volumes are relatively fixed and not easily comparable. So, when it comes to volume ratios in reactions, this law belongs strictly to the gaseous world. Let's recap what Gay-Lussac's law taught us. Gases react in simple, whole number volume ratios. The law holds true only when gases are at the same temperature and pressure. It laid the groundwork for Avogadro's law and deeper molecular understanding. This law showed us that gases don't just follow mass-based rules, they follow elegant volume-based patterns too. In the next video, we'll take this even further by connecting it with Avogadro's law and the powerful concept of the mole.